So today we're going to be solving exponential equations with the same base. And what I want you guys to do, also stress this as same base, is I want you guys to do number 1, number 2, and number 3. Pause the video and play it once you're done. So if I look at number 1, we have 4 to the 2x plus 5 equals 4 to the 5x minus 13. If you think about it in simpler terms, if I have 4 to the x equals 4 squared, what does x need to equal? Well, x has to equal 2, because if 4 to the x equals 4 to the second, then our exponents have to be equal to each other. And that's going to be the logic we're going to do pretty much for the whole day today. So for number 1, we have the same base. We know that their exponents have to be equal to each other. So we're going to set the exponents equal to each other and then just solve it like it's a normal equation from there. We get our x's on one side and get our constants, everything else on the other side. You have 18 equals 3x and x equals 6. And you can plug that back into the original equation. Plug in x, 6 for x and 6 for x. And you'll see we should get 4 to the 17th equals 4 to the 17th. So that checks. So what's different about number 2 than number 1? Well, number 1, we have the same base. We have 4 and 4. Number 2, we have a base of 3 and a base of 9. So it's a little bit different, but we want to solve when they have the same base. So what you need to do for number 2 is you need to make it so that they have the same base. So when I look at the left, it's 3 to the x minus 1. When I look at the right, it's 9. I can write 3 or 9, one of them, to have the other base. So when I look at 9, I can write 9 as 3 squared. So now, look at what happens. What does that accomplish when we rewrite the equation like this? Well, each side has the same base. So now we can just set the exponents equal to each other, solve for x, and we get x is equal to 3. And in number 3, we're going to want to do this of the same exact thing. So we have 3 to the x plus 1. And on the right, 3 and 9 don't have the same base, but we can write 9 so it has a base of 3. And how can I do that? Well, that would just be 3 squared is equal to 9. So it'd be 3 squared to the 4x minus 3. But this isn't fully simplified yet. We want to simplify our exponents as much as possible. The left side of the equation, that is completely simplified. But when I look at the right side, what do we do when we have a power to a power? Well, you multiply those exponents. So off to the side, you have to do 2 times 4x minus 3. Distribute that in. You'll have 8x minus 6. So that would be 3 to the 8x minus 6. Now we have the same base. Exponents are simplified as much as possible, so we can set our exponents equal to each other and solve. Get the x's on one side, get everything else on the other side, and you'll have 7 equals 7x. So we divide by 7 on both sides. You should get x equal to 1. So the key of today is making sure we can have the same base on either side. And once you have the same base, make sure the exponents are simplified all the way, and you just set the exponents equal to each other. So that is pretty much all we're doing today. So what should I be able to do by the end of the day? I can solve exponential functions, or I should say equations, by rewriting each side as a power with the same base. And you might be wondering yourself, what if I can't rewrite the same base? For today's notes, we're always going to be able to write it with the same base. Next unit, we're going to be able to solve it when we can't rewrite it with the same base. So let's go to the next page. On the next page, we have number 1. Notice our bases are different. We have 2 as the base on the left and 8 as the base on the right. But which one can I rewrite? Well, I could write 8 as 2 to what power? I can write it as 2 to the 3rd, because 2 to the 3rd is 8. And then look at that. We have the same base. We have 2 as the same base. So now what do we do when we have the same base? We can just set the exponents equal to each other and then solve from there. So 3x equals 9. X has to equal 3. You can check it. It's going to work out when you plug 3 back into the original equation for x. Let's look at number 2. Number 2, we have a base of 4 on the right, on the left, and a base of 8 on the right. All right, so what could I do to write these that have the same base? I want you guys to take a minute and try and rewrite this one. Pause the video and play it once you're done. So we can't rewrite 4 to have a base of 8, and we can't rewrite 8 to have a base of 4, because 4 squared is 16. So in this case, what are we going to have to do? We're going to have to rewrite 4 and 8 instead of just like 8 in the last one. So what can I rewrite 4 as? Well, I can rewrite 4 as 2 squared is equal to 4, x plus 1. Oops. And I can rewrite 8 as 2 to the third, and don't forget the other exponent of x out there. So now we had to rewrite both bases, but now we have the same base. So we want to simplify the exponents as much as possible. So power to power, you multiply. So 2 times x plus 1 would be 2 to the 2x plus 2, because you're multiplying that 2 into both terms, equals 2 to the 3 times x. Well, that's just 3x. So now we've simplified the exponents as much as possible. We can set them equal to each other and just solve for x, and you get 2 is equal to x. And you can check it also if you want to. Last one, number 3. I want you guys to take a minute. Try this one. Pause the video and play it once you're done. So how could I rewrite this so we have the same base? Well, 6 is in our numerator here, but 36 is in our denominator here, so it looks like it's been flipped. So we have to flip 1 over 36 to get 36 over 1. So I'm going to write it as 36 over 1. I'm going to kind of do this in 2 steps. If you want to do this in 1 step, that's fine. I'm just going to break it down. So I'm going to do it in 2 steps. So I'm going to write 36 over 1 to the negative first power, because that's going to be equal to 1 over 36. That's how you get that flip. And then, okay, so how am I going to get 36 to write as 6? Well, 36 is just 6 squared. So I can rewrite that as 6 squared. So when I do power to a power, that's really 6 to the negative second power equals 6 to the 2x. And you guys could have, you definitely could have done this a different like logical process, and you could have like just like probably skipped right to 6 to the negative second. That's fine. I like to do it in 2 steps because it's more difficult to me to see that all in 1 step. So I break it down like the flipping first, and then I rewrite 36. So you don't have to do it like that if you don't want to. And now we have the same base, so we set their exponents equal to each other. Solve for x, we get x equal to negative 1. And you can plug that in. 1 over 36 equals 6 times 2 to the negative 1. That'll be 1 over 36 equals 6 to the negative 2. And we know that is the case. So I want you guys to just pause the video and do the checkpoint 1 through 6 and play it once you're done. So there's 1 through 6. You could also check your answers if you want to for each of these. I would highly recommend it. I kind of wish I did for 1 through 6 to make sure they're all good, but they should all be correct. If you look at number 1, we had to rewrite both the bases. Look at number 2, we just had to rewrite the left base, 100. Number 3 and 6, think about negative exponents. When it's flipped, you have to have a negative exponent there. And number 4, you first have to get the 60x by itself. So add that 5 on both sides, and the question becomes a little simpler after that. So that's it. The rest is just to finish, the rest of class, just finish the classwork. There's some challenge questions at the end. But yeah, that's it.